Hello YouTube, hi, this is Fahad from Future Phones, and today I have a Fujitsu laptop to repair, and I wanted to share the repair of this video. The problem with this laptop is it does power on, however there is no display on the LCD. So I will just give it a quick check and we will diagnose it. Let's see how it goes. So this laptop, I have done some initial checks on it and it is giving all the powers, and there is no display. So I have just connected it to my DC power supply, and it's a 19 volt at the moment, and 5 amps selected, and I will just go on to this one, and this is the LCD screen. I will just power it on now and see if there is any display. Yeah, powered on, and you can see there is no display on this screen, so no display at all. So we will do our initial checks, how we do it, and we will check some voltages as well. The good thing about this one is there is no shortage on the 19 volt rail, so we are not looking for any shortage on board. However, we'll follow our SOPs and we will check if all the voltages are present. I'll just power it on again, and I will bring my multimeter on the screen also. Just give me a second. Okay, multimeter on. So my multimeter is on now. It's on the display screen. Hopefully it's synchronized and is giving the display. So I have selected the DC range to check the DC power on the coils. Okay, so we have one coil here, so we'll check here. We have a 5 volt on this line, and we have a 3.32 volt. Sorry, it's just multimeter is just playing about. Just fix it. It's better now, I think. Yeah, so we have voltage on this coil and we have voltage on this coil. 3 volt is also present, and we have a 1.5 available here. I'll check some V core and GFX lines here. So V core is present and V core here is present. I think these two are V cores and this is the GFX. I've not looked into the schematics yet. And we have a 0.8 volt available, and we have no shortage on this charging coil also. So we have a 1.81 available also. So there is all the voltages are present. Now we will go into the signal level of this board, because the voltages are present, so we need to look into the signals now, if the signals are present, and if we have clock and PLT reset available, then we will be looking into the data. So clock is available on this line at pin number on this Super IO. We can check the clock. Let me just go into the microscope first. Yeah, and why are we having this here microscope? What is this? Multimeter. Don't want multimeter on this one. Okay, so we will quickly Right, to check the clock we need to use the DSO, and I will try and get the reading, and we will share the DSO screen. I'll see if this we can show you the clock signal. So we will check the clock signal on pin number 13 of this Super IO. This is ITE. So let me just get in focus. So you're supposed to get this clock signal on pin number 13. So if I put my probe of the DSO on pin number 13, I should get the clock signal. I can share my desktop and you can see the clock signal is available. You can see that. So we have a clock signal available on pin number 12. Now I am testing the pin number 22, which is the PLT reset. So pin number 22, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22. I'll check if we have PLT reset available here. PLT reset is a voltage, and we can check it whether with the multimeter or with the DSO. Let me just go on to the DSO. You can see this is the, I think it's the 3.3 volt. So I'll check it with multimeter also. Okay, so we have 3.3 volt available here. We'll check it with the multimeter quickly. Why we don't have multimeter on this screen? Okay, we have multimeter now. Well, let's check pin number 22. So this is 13 14 15 16 17 18 19 20 21 22. So we have 3.3 volt available at pin number 22, and this is the PLT reset. Now the next thing we are going to check is the data, which is on the BIOS pin number 1, and we have a BIOS here. So we will check if we have, so we have voltage here, but we do not have the right data possibly. So let me go back to the I have just added the screen for the DSO on this same screen. So I'm gonna just power it off now. First, laptop is powered off, my DSO is ready. You can see there on the screen. I will power it on now, and we will see if we get the data formation on the, okay, we have data, but it only came once. It did not the signal, if you can see, signal just came once, twice, third time now is a bit fluctuated. Yeah, you can see the data is forming, but it's not regular on the DSO. So the signal is not constant for this BIOS IC. So I will reprogram it. Okay, I'll just power it off first. Get rid of this DSO screen for now. So the BIOS could be corrupt. I'll just power on my hot air station, get the BIOS out, and put in my SVOD programmer. Just in the meantime, I'll open the SVOD as well. The SVOD programmer is on. It's almost ready. So just get this BIOS out. Use some flux. Oh, it's okay. So the BIOS is on. Put the BIOS in the ZIF socket. You can see this is the ZIF socket. So pin number 1 will go here. Yeah. Away. So it's ready. Okay, let's see. And my SVOD programmer. I'll share my desktop. I will share the window for SVOD here. So now you can see the SVOD programmer is ready, and I will just select the 25 SPI 25 flash, and voltage I will go for 2.5 volt, and I will say read ID. Test pins are okay, so it has read the pins, and I'm going to read. It's reading whatever is on the BIOS now. I'll make a backup for this. So this laptop is A512 Fujitech. It's a Fujitech, isn't it? Yeah, Fujitsu A512 FUJITSU A512. So I'm going to put this in the red, and I have downloaded the BIOS for this model already. So let's see where it is. Oh, here, A512. I downloaded this from Winafix, and I'm going to just write it. So while it's writing, I can just quickly check if the BIOS that I read is the same size, is 8192 KB, and the one I'm installing is 8192 KB also. So there's the same bytes, same size of the BIOS is, so there shouldn't be a problem, most likely. Come on, write it. Okay, so the BIOS is written. I'm just going to power it off and move it from this window. Now this BIOS is ready. I'll just move it out of the way. here is my board again. I will install this BIOS back in there. I use some flux. I think I should go for the microscope. So the BIOS is here. Just retouch it with the soldering iron. Okay, just clean it. Okay, now we will check on the DSO how it looks after we have put a new program on the BIOS, and it should have made some difference. Okay, so the probe I will connect to the first pin of the BIOS and power on the laptop from the pin. Let's see if it powers on. Yeah, it powered on. Now you can see. Yep. So data is forming now, and you can see the voltage is constant. Is continuously is on 3.5, and we have data coming as well. So when the laptop powered on, there was the chip select happened, and we could see the data going through that line also, and the voltage is constant now. Before, the voltage was dropping from here to 0 volt also at some point. So something has changed. Let's check the display on the LCD screen now. So I will power it off again. So DSO is off now, and I will select this camera now, and let's see if we have a display now. Ouch. There is the power. Okay, so connected, and you can see the LCD now. Powered on. Should have some display now. Oh, still no display. So there is no display at all. Alright, no problems. Let's check the display on the HDMI port now. On the external LCD. We'll connect, and I will power it on again. It's powered on. We just select external display is on. Oh, we have display, you can see here on this screen. So we have display. It's quite possible that this LCD could be faulty, but we need to check it. Okay, I'll power it off. Okay, so remove the HDMI. We had display on the HDMI, but it's not coming on this LCD. So this LCD could be faulty, but before we come to any conclusion, I want to check the connector, if it is receiving what it's supposed to receive. Let me just get my Flex BV on, and I will just select the desktop, and this is the schematic diagram. Okay, so the connector we are looking for is possibly this one. Okay, which one is in the corner? So it is probably this one. It says it's the LCD connector. Script. Yep, this is the one. So when, let me just see if you can see what I see. Yeah, you are on the desktop, so that's fine. So LCD, this is the LCD connector. I'm going to quickly check if all the voltages that this schematic says should be present, if they are there. Powered on the laptop, and let me just adjust some of these things first. So the laptop is on now, and I'm sure you could see it also. So we will quickly check the voltages that are supposed to be present, if they are present. So on this LVDS connector we are receiving 3 volt on pin number 29. We are also receiving 3 volt on pin number 28 and 26, and we are receiving LCD VCC and V backlight. So we'll check if the voltages are present. These voltages are present. If they are present, then we will go for the LCD and check if we need to change the LCD. So if this is, I don't know, if I hope it's not blurry for you guys. Let me just adjust it. I'm sure you should be able to see this now. So this is the LVDS connector, and we are going to test if the voltages are present. So we will go from here. This is pin number, if I see, this is pin number 1 here and pin number 2 on this side. 1 2 3 4. So that's how it goes. So we are looking for 3 volt at pin number 29. So if this is pin number 1, so we need to go to pin number 29. So if this is 39, so we need to go back 10 places once. So 39, 38, 37, 36, 35, 34, 33, 32, 31, and we wanted to see on 33, pin number 33. So we get 3.3 volt, which is okay. Now this is the pin number 29, so we need to go, oh, we'll count them accordingly. 1 3 we are looking for pin number 29 in the first place. 1 3 5 7 9 11 13 15 17, okay, and 19, 21, 23. OCD power, what is there? Well, there is a 3.3 volt available on OCD power also, so that's okay. So pin number 23 is fine. We'll go for 23. So this is 25, we have power here, and 27 we have power here also, display on. And then we go for 29, we have power on number 29, that's okay. And 31, and so 31 we have 3.3 volt, so 33 should also have 3.3 volt, that's fine. And these three are NC, so we won't get any power here. So right across these pins we have V backlight. So let's see what is on V backlight. So we are getting almost nothing. Is 0.0016 and dropping. So we don't have this voltage, so that's for one thing we know. Let's check the other voltages which are on pin number 28. So if I come here, these three pins are same, they don't have power right now, so we'll skip another three pins, 1 2 3, and then we have pin number 28, which is this one. So on pin number 28 we have 3.3 volt, and on pin number 26 we have 3.3 volt. So we have all the powers except for the V backlight. So let's check what is the V backlight. So do you see that I have checked all these pins, and we have powers coming on all the pins except for V backlight. So we will check what V backlight is. We will go back to the schematics again, and from there we'll try and trace what the V backlight is. Okay. So the V backlight, if I go V backlight is here. I'm gonna click on V backlight here, and V backlight is on these pins, and this is the test point. Okay, so we have capacitor and a fuse. So we have a fuse here. Let's look for this fuse. What is this fuse doing? Stripped. Come on. Where is V backlight? So I'll go for this capacitor first. Right, okay, we found it. So this C492 is a capacitor, and basically, so if you see, this is the fuse. So on this side, number 1 pin is the VIN, which is coming from the DC circuit, DC charger. So this VIN is here, and then it goes to across this fuse, and it changes itself into V backlight. So you can see that VIN, and it's going into V backlight. So we need to check if V backlight is present on this fuse. I think if the location of this fuse is probably on the other side, yeah. So Yep, it's here. Let's check on the fuse. I want to go to the microscope now. So, because could not see it. So this is the fuse, and we should get 19 volt across this fuse. So we are getting 19 volt on the win side of this fuse. So if you could see on the schematics, it was the pin number 1. So this is pin number 1, this is pin number 1, and this is pin number 2. So we are getting 19 volt on pin number 1, but it's not going across this fuse. You see that? Okay, I'm just gonna take the power off. I will check for this fuse first, if this fuse is any good. So multimeter is set to beep range now. So it's not beeping. Something happened to this fuse and it's not beeping. You see that? So this fuse should beep. So it could be more voltage or something happened. This fuse is just blown, and so the 19 volt is not going across from number 1 to number 2. So from on this point is VIN, and on this side is saying something VS backlight or something. What was it? V backlight, yeah. So this is V backlight here, and this is VIN. So we are not getting V backlight here, and this V backlight should go past these capacitors, and it is supposed to reach that connector, and from that connector is supposed to reach to the LCD. Most likely this is the fault, and hopefully LCD should be fine. For this fuse, I'm going to see my donor board if I have any fuse similar to this. I have this board here. I'll just look through this board and I'll see if I have any fuse. Okay, this is I don't see a fuse. I could just run a wire as well, but running a wire is a risky business. If something happens next time, then it's going to blow the LCD. Okay. Okay, I found one fuse. It is next to the HDMI connector on this board. I'll quickly just take this out. Oh, before I take it out, I'm going to check it. I'm going to check if it is not faulty. Yep, it's beeping, so this is good. This fuse is good. Okay, let's take this fuse out. I need some flux. Okay, got the fuse here, and this fuse needs going in the bin. Now use the replacement. fuse. Okay, let's check it again if this fuse is good. Yep, it is good. So our problem was 19 volt for the V backlight was not going past this fuse. Okay, we'll just put the power in, and I'm quite sure this 19 volt is coming from the wind, so it will travel before trigger. So let's see. Yeah, it is traveling before trigger. So before you press the switch, this 19 volt is available at this point, and it is going past this fuse. Come on, why is okay? Let's see, is it blown again? We have 19 volt, and we should have 19 volt here also. Let me just retouch it. Maybe it's not soldered properly, there is something left. Quite possible that it's not soldered on properly with the hot air station, so I'll just use some solder here. Okay, let's clean it. I don't know if you can see that, sorry, it's just okay, let's check it again. I'm quite sure this 19 volt should go past before it triggers. So before it triggers, yeah. Okay, we have 19 volt here. It should be here also. Yep, we have 19 volt now. So when I installed this fuse, I think it was not soldered properly with the hot air station, so I had to retouch it a little bit. Okay, now time for the checking on the LCD. Let's see what happened to the LCD. Is it giving display on the LCD now? It should, because the 19 volt is available now. Oh, we can test 19 volt on the connector as well. Well, I think it should be available. Because the fuse was faulty and we have replaced the fuse, so keeping a good faith, we will just check the LCD now. Okay, so this LCD is here. I'm going to power it on with this connector. We should get display now. Yep, we have display. Look, I don't know if you can see that, it's just it's awkward right now. Oh yeah, we have a display. Yep, we have display. So we got the display back on the LCD. The fuse was faulty, the BIOS was faulty also, because I checked it earlier with the HDMI port and it wasn't giving any display on the screen. But after I done the BIOS programming, I could see the display on the HDMI port, but there was no display on this LCD. However, now after I have replaced the fuse that was blown, we have a display. So this is a successful repair, and I'm quite sure you must have learned something from this video, because the fuse blown up issue comes quite a lot of times, and you can see now. So we have display now. Yes, so it's fixed and the laptop is fixed, and it's about time I leave now. So I will give it to my colleagues to put it together. So this job is done. I hope you must have learned something from this video. Do like and subscribe to our channel, and if you have any suggestions or if you have any questions, you can leave it in the comment section, and we will try our best to answer you. Thank you very much. Thank you for watching, and have a nice evening. Thank you. Bye bye.